What is going on, guys? Welcome back. In today's video, we're going to learn how to build an encrypted chat in Python. So let us get right into it.
It's not a game, it's a rich thing.
Alright, so I already have quite a lot of tutorials on this channel on how to build a chat in Python, be it a TCP chat, a UDP chat, a TCP chat room, a web chat in Flask. And in today's video, we're going to build an encrypted chat, which means that the communication between the individual clients is going to be encrypted. We will not send any clear text messages. We will encrypt the messages at the sending client and they will be decrypted at the receiving client, making it basically impossible for me as a third party to just listen to the network traffic and say, hey, this is the content of the message. I can read it as well. Just because I'm listening to the network connection, I can see what you guys are talking about. This is not possible when the connection is encrypted. And in fact, I'm going to show you the difference between encryption and non-encryption by using Wireshark and actually listening to the network traffic, in this case only on my machine, but this can also be done in a network if you're a router or something. You can just listen to the network traffic that's happening and you can see, okay, what package is being sent. You can extract the messages in clear text unless they are encrypted. So this is what we're going to do today in Python, and for that we're going to use one external library called RSA. This is going to be the library that we use for the encryption, and the rest is going to be done in core Python. So we're going to use the socket module, the threading module for the connection and everything, and we're going to use RSA, the external module, for the actual encryption. And for that, we're going to open up the command line and we're going to say pip install RSA, and this is asymmetric encryption. So this basically means, in a nutshell, we have a private key and a public key, and the public key is known by everyone. So if I have a public key, you can know it, everyone can know it. There's no secret about this key. Everyone can know this key and everyone can use this key to encrypt a message for me. And this encrypted message can only be decrypted with my private key, which hopefully only I know. So the private key is also sometimes called the secret key, should be kept secret at all times, so only I can know it, because that's the only way to decrypt the message. And it's called asymmetric because we use a different key for the encryption and a different key for the decryption. It's not like using a password that you just, use to encrypt and decrypt something. You use a public key that is known by everyone. Everyone can use that to encrypt a message specifically for you, and only you can decrypt that message with the respective private key. And it's basically impossible to derive the private key from the public key. So that's the basic idea here, and this is what we're going to use as an encryption here. And we're going to start by saying import socket. We're going to also import threading, and we're going to say import RSA. And before we talk about anything regarding the encryption, we're going to have a basic choice because we want to use one script in this video for the client, and we don't want to use a server script and a client script. So we want one central script, and you can choose whether you want to host or you want to connect, because one client will have to host a conversation and one client will connect to the hosted socket, because you cannot just have two clients talking to each other. One client has to also host a connection. At least when we use TCP and UDP, we could just send packages. So for that reason, we're going to say choice equals input. Do you want to host? This is option 1. Or do you, or let's say, or to connect, option 2. And then we say if, maybe not a question mark, maybe colon, if the choice is equal to 1, then we're going to host the connection. So we're going to say server equals socket.socket, socket.afinet, and socket.sockstream. That basically means internet socket TCP, because connection-oriented protocol here. If you want to use UDP, you would just say sockdgram for datagram. And then we say server.bind, and we bind it to the local IPv4 address, which can be found out in the terminal on Windows by saying ipconfig, so in the command line. We just go to the Ethernet adapter and we go to IPv4 and we copy this IP address here, and I bind it to the tuple of this and the port number 9999. That's the basic idea. And now we say server.listen. And this is going to be a client that will only accept one connection, so we don't need anything to handle. We don't need multiple connections, which is why we're going to call the accept function only once. And we're going to say that the client and the address that is connected, actually we don't need the address, so we can just leave this as an empty, as a placeholder here, as an unnamed return value. So client is going to be equal to server.accept. So when a client connects to that server, it's going to just accept, and this client here will be our communication method to that client that connected. That's the idea here. And then what we're going to do, or actually let's do that later on. We're going to exchange the keys here because the other client needs to know our public key and we need to know the public key of the other client so that they can encrypt something for us and we can encrypt something for them. But we're going to add this here in a second. So let's just accept the connection for now. And let's say also otherwise, or actually elif, the choice happens to be 2. And then we're going to say that the client is equal to socket, again, socket, AF-INET, sock stream. But this time we're going to connect client.connect to, in this case, we're going to use the same IP address. Of course, if you use this across the network or maybe even in the internet, you would want to specify your IP address here and the other person would specify the IP address of your public IP address, and you would specify if you connect the public IP address of the other person. But in this case, all of this happens on one machine. So we're going to do it with the same IP address. Of course, you can also ask for input. So you can say IP equals input, enter the IP address if you want to. But in this case, I'm going to use only my IP address, so that's not necessary. And then here we would also exchange the key. Otherwise, we're going to say exit because that's an invalid input. And then essentially all we need to do is we need to send messages and receive messages. So we're going to have one function that is going to run in a separate thread, which is going to be the sending messages function. Is going to run with a parameter C, which is going to be our client. And we're going to say while true, we're going to be asked for new messages. So message is going to be input. What do you want to send to this person? And then we're going to just say C send message.encode. And we're going to print you and then whatever you sent to the other client so that you have a protocol, a lock. And then we're going to also have a receiving messages function, which is going to say while true, just print partner, whatever the partner says. And this is going to be C receive 1024 bytes decode. That is the idea. And then we're going to just say threading.thread. We don't need the input here. Threading.thread. One is going to target the sending messages function. We're going to pass as arguments here the client. And one is going to be the receiving messages also with the argument client. What's the problem here? Client can be undefined. Okay, we're not going to care about this here because it's not going to be undefined. And one nice thing that you can see here is that the client is always going to be the correct object to talk about because we don't need the server. The server is only made for accepting the connection. The client is the accepted connection. So this is the client we use to communicate with the other client. And here we also have the client that we use to communicate. So basically, after going through this block here, the client is going to be the client and we can just do it like that. So this should already be an unencrypted chat. So I should already be able to run a terminal here. And what was the keybind for split? I hope this is it. There you go. I'm gonna navigate to my current working directory, which is this one. And I'm gonna do this here as well. Wrong directory. And now we're going to run main.py here. We're going to run main.py here. And I'm going to say I want to host, and I'm going to say I want to connect. And this crashed the script. Why is that? Oh, because we need to start the threads as well. That is the issue. So let's do the same thing. I want to host, I want to connect. Hey, hello, what's up? Not much. There you go. So this works. This is the ordinary connection. Now we're going to encrypt this connection. So we're going to use RSA, first of all, when we start the script to create our own public-private key pair. And usually you don't generate public and private key for every session. You have your public key for a certain amount of time and you just put it on your website or something, on a public website, and you don't necessarily generate it for each session, but in this case we're going to do it like that. We're going to say that the public key, private key is going to be equal to RSA new keys 1024 bytes or bits, I'm not sure. And then we say also that the public key of the partner is going to be none by default. And we're going to get it then via the socket connection. So in this case here, once we accepted the connection, we're going to start by saying client.send. So the hosting person, the hosting client is going to send the key first. We're going to send to our other client the public key, but of course, in order to be able to send it, we need to package it as bytes. So we're going to say public key.save pkcs1, and this is going to be sent, was it like that? Yeah, we need to specify the format, which is PEM. So basically we take the public key, we save it in this format PEM, and then we receive also the public key of the other client by saying public of the partner is going to be equal to client receive 1024 bytes. And this is going to be the basis for the public key. And we're going to say RSA public key, or what was it? RSA public key dot load pkcs1, whatever we get here. And this is how it works. We're going to do the same thing down here, but we're going to do it the other way around, because when one client is sending, the other has to receive. So the hosting client will send first and then receive, and the connecting client will receive and then send. And then the only thing that we need to change now that we have that is we need to encrypt every message and we need to decrypt every message. So instead of just sending, we're going to say RSA.encrypt. We're going to encrypt the message.encode. So the encoded message will be encrypted with the public key of the partner, so that the partner can then decrypt it with the private key. And we're now the partner, or we're now we're receiving from the partner. In this case, we're not just printing whatever we get here. We're going to say that what we want to print is RSA.decrypt, and this is going to be whatever we receive here in the form of bytes. So we're not going to decode in here. We're going to receive whatever we receive, and it's going to be decrypted with our private key. And this result here will be decoded. That's that. So let's see, before we look into Wireshark and package sniffing, if that works. So let me just split this here again. Let's go to the Python directory. Okay, wrong one again. I changed the binding recently to have a different functionality. So I'm going to navigate here. And then I'm going to run main py again, run main py again. I want to host here. I want to connect here, test. Hey. Okay, so you can see everything is clear text, even though it's encrypted actually. And now let's see what the actual difference is, because right now we just had the same functionality as before, but what changed behind the scenes? So for that, we're going to open up Wireshark. If you don't have Wireshark, you need to install it. The installation process is not too complicated. You just download Wireshark and you run it. And then what you can do is you can capture certain interfaces. So I can go to options here. I can choose an interface. Usually, of course, you would want to choose Ethernet or Wi-Fi or something. But since this is happening here on the same machine, so since I'm sniffing and listening on the same machine, I will go with the loopback traffic, because at the end of the day, I'm sending myself some messages on localhost. So I'm going to start this network here. And you can see now packages are being sent all the time for all sorts of reasons. You don't have to look at everything here. But let's briefly just disable the encryption. So we're going to say they can still exchange keys, but we're not going to encrypt the messages. We're just going to receive and decode. And we're going to just send without encryption. And then we're going to see how easy it is to get the content of these packages. So I'm going to run here. Again, maybe I should leave this open. There you go. Main. And now I'm going to say I want to host here. I'm going to connect here. And now I'm going to say hello world. What is up? My secret is that I love MATLAB, but I am afraid to admit. Rightfully so. Let's go into Wireshark and let's see if we can see some packages. I can stop capturing now, and you can see here that we have some packages from this IP to this IP. So not just from localhost to localhost, but from specifically this IP to this IP. And if I click on it, you can see that I see something that no one wants to see, someone confessing his love to MATLAB. And you can see my secret is that I love MATLAB, but I'm afraid to admit it, or to admit. You can see I just listened to the packages, and this package contains data, 58 bytes, and this is clear text. I can just read what's in it. Now we have a second package here with some other data, and we should have more packages containing more messages. Here I can see what is up. Then I can see here hello world. So you can see I can just look at the packages with Wireshark and see what's happening. Let's do the same thing now with the encrypted lines of code. So now we encrypt every message and we decrypt every message, and I can run this again. So I can, okay, I cannot close this. I have to restart this. Sorry about that. Let's navigate there again. I'm going to run main py here. I'm going to run main py here. Host, connect. And now let's run Wireshark again. Options, loopback, start, continue without saving. Listens again to some packages. And now I can just go ahead and type some messages. Hello world. How are you? I am afraid to admit that I code in MATLAB. And now we can go to Wireshark again. We can stop the capturing and we can look at the same packages. So let's look again. There you go. Here we have again source, the IP address, and destination, the IP address. If I click on it, you can see now I still have data, but it's always going to be 128 bytes and I cannot see what's in it. So I cannot read any of that content here. And we can also look at the other packages. So I can scroll up. Here we have another message, again, 128 bytes. No chance to see what's in there. So I don't know. I cannot see the content of this message. I don't know actually what would happen if I include a very long message. Probably I would have some problems. Let's try. Maybe we can find out. I mean, actually I stopped capturing, right? But you can see the difference. You can see that we can no longer just sniff the network connection. We can no longer just listen to the connection and see what two clients are communicating about, because we only get some random bytes that we don't know how to interpret. Now I'm going to send a bit more content. Maybe we're going to get either an error, or maybe we're going to get larger packages, or we're going to get 128 again. Okay, no. Overflow error. Okay. But you can see the difference. You can see that when we encrypt the messages for our clients, there's no difference in experience, but we are not able to just listen to the connection and see what they're talking about, which is very good, because now we have a little bit more security. As long as you keep the private key private, it's basically impossible to to unencrypt these messages. And this is how you do that. This is how you build an encrypted chat in Python. Alright, so that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting a like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video and bye.